Hey everyone, and welcome. Today we are jumping into a really important skill for any draftsperson: how to accurately enlarge and reduce plain figures. This is such a powerful technique, so let's get right into it. So let me ask you something. Have you ever wondered how an architect manages to fit an entire skyscraper onto a single drawing board? Or how an engineer can show you all the tiny, super detailed parts inside a smartphone? Well, the secret is something called scaling. And trust me, it's a technique you're going to use in pretty much every great design you ever create. All right, here's our game plan for today. We're going to start with the why. Like, why is scaling so important in the first place? Then we'll dive into the math behind it with something called the scale factor. We'll see how it works on basic shapes, and then, this is the best part, we're going to learn two awesome construction methods to do it ourselves. After that, we'll wrap it all up, and I'll give you a little challenge to try out. So, first things first, why do we even need to do this? I mean, why not just draw everything its actual real life size? Well, it really comes down to one simple thing: practicality. Think about it. A building is way too big for a piece of paper, so we have to reduce it. And a tiny microchip is too small to see, so we have to enlarge it to show the details. But here's the absolute key: scaling lets us represent any object perfectly, keeping its exact shape and all its proportions. It's a non negotiable skill in just about every design field out there. Okay, so if we're going to do this right, we can't just eyeball it, right? We need a super precise rule. And that rule's called the scale factor. Honestly, this is the mathematical heart of this entire topic. So, this scale factor, you'll often see it written as the letter K. It's just a ratio. That's it. It's the instruction that tells us exactly how much bigger or smaller our new drawing needs to be. The formula's right there. Just take a measurement from your new shape and divide it by the same measurement from the original. That simple calculation gives you the scale factor. This table right here, it makes things super clear. For an enlargement, obviously, the drawing gets bigger. The scale will be a ratio that's greater than 1, like 2 to 1, and you multiply your original dimensions. Now, for a reduction, the drawing gets smaller. The scale is going to be less than 1, like 1 to 2, and you divide. See? Simple. And here's a fantastic visual to help it all click. A 1-to-1 scale? That's just full size, no change. But a 2-to-1 scale doubles the size, and a 5-to-1 scale makes it 5 times bigger. Just look at how that first number in the ratio tells you exactly what's going to happen. The shape, of course, stays perfectly the same. It just gets larger. Okay, perfect. We get the why and we get the basic math. But how does all this theory actually work with the shapes you draw every day in class? You know, your squares, triangles, and circles. Okay, this next part is the golden rule. If you remember only one thing from today, please let it be this: when you scale a figure, the angles never change. A 90-degree corner in a square is always going to be 90 degrees, no matter how big or small you draw it. All we are changing are the lengths of the sides. The basic shape itself is sacred. We don't touch it. And applying it is actually pretty straightforward. For anything with straight sides, like a square or a triangle, you just apply that scale factor to the length of every single side. Now, for a circle, it doesn't have sides, right? So you just apply the very same scale factor to its radius or its diameter. It's the same principle, just a different measurement. Okay, let's get our hands dirty with our first practical method. This is the one you'll use when you've got your calculator and your ruler ready to go, and it's all about simple, clean calculation. The steps here are super simple. Check it out. First up, you've got to know the lengths of all the sides on your original shape. Next, look at the scale you've been given. Let's say it's 3 to 2. That just means you'll be multiplying by 3 divided by 2, or 1.5. Third, you do that math for every single side. And last, you just take your new dimensions and carefully draw out your new figure. Let's run through a quick example so you can see exactly how this works. Say we have a square with 20 millimeter sides, and our scale is 3 to 2. The math is easy. 20 millimeters times 3 over 2, that gives us a new side length of 30 millimeters. So you would just draw a new, perfect square, but this time with 30 millimeter sides. Job done. All right, you ready for method number 2? This one is pure geometric construction. It's a classic technique that relies on the precision of your drawing instruments, not a calculator. It's called the radial line method. Okay, I really want you to focus here because this is the expert's method. Seriously, mastering this shows real skill. It's all about using your T-square and your set squares to get those perfectly straight and parallel lines. This is what precision drawing is all about. Okay, let's break this down step by step. Don't worry, it looks more complicated than it is. So you start with your original figure and you pick a point P, the pole, somewhere outside of it. Step 2, you draw light construction lines from that pole straight through every corner. Now for the scaling part. Let's say we want a 3 to 5 reduction. We'll focus on one of those lines, say the one going to corner B. We divide that line into 5 equal parts. Then we mark the third division point. That's our new corner, B1. And here's the most important part. You use your set squares to draw a line from that new point, B1, that is perfectly parallel to the original side. You do that for all the corners, join the dots, and you've got yourself a perfectly scaled figure. Awesome job, everyone! We have covered a lot today, from the basic ideas to some pretty advanced construction. So before I let you go, let's do a super quick recap of the big ideas. Just try to lock these 5 points in your brain. 1, scaling is all about size, not shape. The angles always stay the same. 2, if that first number in your scale is bigger, it's an enlargement. 3, if the first number is smaller, it's a reduction. 4, you've got 2 great methods in your toolkit, calculation and construction. And finally, number 5, be neat. Precision with your drawing tools is everything. All right, all that talk leads us to your challenge. It's time to put what you've learned into practice. So go on, grab your T-square, your set squares, and your pencil. Your mission, should you choose to accept it, is to draw a square with 25 millimeter sides and then enlarge it to a scale of 2 to 1. You can even try both methods we learned today and see which one you like best. Good luck and happy drawing!